Hello. Today we are going to be taking a look at shaders, more specifically the openGL shaders used in jit.gl.slab, and we're going to be looking at how to manipulate footage using the GPU rather than the CPU, which Max tends to depend on. Now, I'm not going to look in detail at sort of materials and how to apply them, because Max is actually better at doing that with other objects. I'm going to look at how to offload onto the CPU using files, and we're going to do that by looking through this here, tutorial 34, a slab of your very own. This teaches us how to mix 4 different video inputs using the CPU. Now, I'm really just going to make an altered version of this, but talk through each step in detail, trying to help you understand what all the code means and how it's going to manipulate. So we'll get rid of that for now. The way that the shader in Max works is that you get something called a vertex shader and a fragment shader that comes together through an Xml Shader File that then Max references and makes use of all the inputs. So our vertex shader defines our inputs and then sends locations of them to the fragment shader. In the fragment shader, that's where we make our changes. So in this case, we're going to control color of pixels. They're all set to the XML file that is then passed into Max. So you can see here the vertex shader is responsible for the coordinates of different texture inputs. It passes out varying variables into the fragment shader, and what this means is it passes changing locations. And the fragment shader, that's responsible for setting the final colors of each individual pixel as we go through. Now, if you don't have any experience with programming things like JavaScript or C++, then this might be a bit heavy for you to start with. So I recommend looking at something like Processing for Beginners, where you can learn a lot of all the basic how to program. I've got Sublime here just because that's what we're going to use in a minute. But I'm going to start with the Max patch. So the Max patch is actually fairly simple in this case. What we're going to have 4 videos, so we're going to have jit.qt.movie, 320 by 240, read, and we're going to have 4 of these. I'm going to make a toggle and my standard metro, Q metro. And what I'm also going to have is, because we're using shaders and geometry, we're going to need to include a jit.gl.render. We just need to we need to be able to render the openGL objects that we're playing with. And I'm going to give the renderer a name just to keep everything tidy, because we're going to use a window rather than a P window for once. So let's just call it render. And we keep that up there nice and tidy. Now what I'm going to do here is I'm going to actually bring in 4 different files. Read, first one, let's have dozer.mo. So I'm just going to bring in some of the Max defaults. Movie players don't need to be just movies, so we can have something like chilies.jpg, my favorite red ball, and let's have something exciting like dishes. So I'm just error checking as I go, because it's easy to make a mistake here before we even get onto the code. Magic. So all 4 of our video inputs are working independently, all putting up to our P window. Next, what we're going to do is we're going to pass these into the jit.gl.slab, which processes texture data. And by default, these are set up to accept 2 inputs, and most of the Max default JavaScript files are the XML files. If we bring this in from the help, I'm going to push the slab into a video plane just because we need to be able to actually see what we're doing. And for the sake of this, I'm just going to change the global scale a bit so things fit a bit nicer. I'm going to do 1.3t times 1 times 1. And then what we can do is, if we name these the same as our renderer, That means it's going to pass the images to them. So jit.slab render jit.window. So now you can see here we have our jit.window that's called render, that's displaying the mix of these two inputs. Now the default ones in Max, we've got things like additive, dodge, glow, all the usual sort of CPU shaders that you're used to. But we're going to make one that mixes 4. So we're going to tell it to change the default inputs to 4. Simple as that. Now when I connect up these, all we're going to see is them just piled on top of each other. It's still going to be glowing, but it's not going to be glowing the second two. That's why the balance seems completely off. What we are going to do is write code that allows us to completely control each of the 4 videos. Now we need to go to, let me just open the Max window. It's getting really angry because of all these 4 inputs. We're going to leave Max for now, and we're going to start writing some code. Now if we refer to my flow diagram, we're going to write 3 pieces of code here. We're going to write a vertex shader, a fragment shader, and then an XML file that tells Max where to go and where to send the variables. So what do we want to actually control in here? We need to say which files it is we want to look at. So we're going to tell Max to reference the 4 inputs on slab. And then we're going to tell the fragment shader to control the R, G, B, and then the A, because it always comes in 4 in Max, values of each of the videos, so we can change the levels between them all. And then the XML file tells Max how to reference these 2 files, and so all the magic happens here. This is just almost a bridge between Max and shading. First thing we're actually going to do is we are going to write our fragment program. I'm going to save my Max file, a new folder, and let's just call it Gsl Tutorial Max Patch. And the reason we're saving this in a separate folder is that that's where Max is by default going to look for all our XML and shader files. The Fragment Program. What this does is this calculates resulting colors from vertex shader. So first thing we're going to do is we're going to define variables for our values that are R, G, B, and A. So we're going to do uniform vec4 A semicolon, select all. Now what uniform means, it's a variable that can only be changed inside this shader. Vec4 means it's a 4 vector variable, so each A, B, C, and D has 4 internal values. So it's like a 4 deep matrix, and they are going to turn out to be red, green, blue, and alpha. After that, we are going to move on to define our varying texture coordinates. So because we've set all of our video players to the same resolution, that's not going to have much of an impact. But having this here means that we can dynamically change the sizes of our videos and our sources without having to rewrite code at any point. Varying vec2 text chord 0. So what we have here, we have a varying variable received from our vertex shader that is 2, which is x and y chords for each of our inputs. And naturally, we've got 4 inputs, so we're going to need this 4 times again. Just like above, where we needed 1 for input 1, 2, 3, 4, we need 1 for 1, 2, 3, and 4. Everything's going to be done in 4s here. Right, okay, so now we have our varying texture coordinates defined. We need to define our rectangular texture samplers. Now what this means is shaders of past only allowed for textures to be in square of each other, so you could have things that were 256 by 256, etc. But having rectangular or non-rectangular shaders means that we can have non-power of 2 texture planes to exist. So we can have a texture that is 320 by 240 rather than 320 by 320. And to do this, we'd make another uniform, because it's internal only. Sampler 2D rectangle, because it's a 2D texture, I'm going to call it text0. Now, sampler 2D rec needs a capital R, is a default of the openGL language, so it's not something I'm making up here. That is just the code for defining a 2D rectangular texture. And now we get into the main bulk of our program, which is void main. Void. We're going to open our colons, and then we're going to do sample our textures. So what this does is it gets the color from our textures individually and calculates the new resulting color of the pixel. Let me just bring that down so you can actually read it. So how do we do that? We're going to need to create a new 4-vector variable because we've RGBA again. Input 0. So the value that's coming on in our first input is equal to texture 2D rec. Again, using the same logic as above, it's instead of we're sampling it, we're making a new texture, or we're looking at the current texture of it. Text0, text core 0, semicolon. So all we're doing here is we're defining variables that are going to be multiplied and added together from our user input variables. So we've sampled our textures, we've looked at what currently exists, we've said look at texture 1 at the coordinates we defined, so it's going to look at each pixel in the 320 by 240 grid and give it a value in this new 4-vector matrix. And finally we're going to tell it to perform the calculation. So we're going to do gl underscore frag color with no U because of America. And then I'm going to do my user defined input times my current value with my second user defined input times the second value, etc. Semicolon. So what this is doing is it's looking at the current value of a pixel on all 4 videos, timesing it by the defined variable that I have and adding them all together, so it works out the resulting color of having 4 images on top of each other. I'm going to save this into my Gsl tutorial as 4-way mix.fp.glsl. So it's my 4-way mix.fragment program or fragment project, and then it's a GLSL file. I'm going to save it. Sublime's going to get angry. I'm going to tell it to use what I've told it to. So now we have 4way.fp.glsl. And now I'm going to make a new JavaScript. And this is going to be vertex shader. So we've done it a bit back to front. Our fragment shader calculates the colors and outputs them, but it requires the information from our vertex shader before it can do that. And that information is these varying variables here. So these are changing and varying variables, as we know from here, are sent from our vertex to our fragment. So the main output of our fragment is going to be our texture locations. So it knows which pixel is which color and how to overlay them. So we're going to define our varying texture coordinates. Again, it's going to be a varying vector 2. Because we only need x and y from this, we don't need to have more than a 2-vector matrix. Text coord 0, copy it 4 times again, and then we go straight into our main program, which is void main, void, because we're not passing any input, curly brackets, the output vertex. Right, I'm going to write some jargon here, and then I'll explain what that actually means. So this is a piece of openGL code that is just required before you can start passing location information for matrices. So we're going to define a global position matrix. So what this is saying here, it's our global position matrix for each of our textures is going to be the modal view projection matrix multiplied by the current matrix. Now, what does that actually mean? What that's doing is our current position, modal is equal to, that turns local into world. That's view equals world coordinates into camera coordinates. Projection equals camera coordinates into screen coordinates. So all we're really doing here is we're saying take what we're saying the value of our current texture is and times it by the modal view and projection matrices all at once. There are other ways of doing this, but this is the most basic one when you're just doing additive shading like we're doing here. If you're including light onto geometry, which again I don't recommend in Slab, you would do maybe modal view, add your light, and then work out the projection matrix after that. This is really just a formality. We need to be able to continue with the shader. Next, we're going to do the actual work where we assign our varying texture chords to the input texture value. I'm going to write out the code and then come back and explain what it's actually doing first, because the code is a bit less English than the rest. So we're going to have text chord 0 equals a 2-vector variable that is the multiplication of our texture matrix. And note the capital T on texture matrix. This is another built-in OpenGL one. We're going to do it to texture matrix 0 and times it by our multi-text chord 0, close brackets, semicolon. What we're doing here is we're assigning our texture coordinates per vertex so that we can access the information and pass it into the fragment shader. So we're basically telling the shader to open up the coordinates that we've sent in that contains, so this is an X and Y for every single pixel on each one of these, and we're telling it to open it up and place it into these 2 default matrices inside OpenGL that is required to pass variables back and forth. We're going to need 4 of these, and we just define a new variant of it for each of our values, and that ends our main. We're going to save this one as very similar to the last, but it is going to be, it's now our vertex program .gsl save. And finally, we're going to need one more file. So we've done 1, 2, we've got our shaders ready. We now just need to tell Max how to access them and use them. So this is our jitter XML Shader File, which has a JXS file name. That's what we're going to use at the end here. Let me just set this to JavaScript so it looks a bit prettier for us. So what is a jitter XML Shader File? So this allows Max access to and control of the variables we have defined in our shaders. So this is a slightly different programming language, but I'm kept it on JavaScript because it'll still keep it colorful for us. So we're going to define our jitter shader, and then optionally we can give it a name, which I'm just going to do 4-way. I'm going to tab in. I'm going to define our first parameter. So this is something that we're going to receive from Max and pass into our shaders. So its name is going to be A. Its type is going to be vec4, because we're going to pass it 4 variables that are RGBA. And then we're going to have a default value for it, which is going to be equal to 0.25, 0.25, 0.25, 0.25. Now, you may be wondering why we set these to 0.25 and not to 1. Because we're putting 4 films on top of each other, all with a default of 0.25, which means that they will add up to 1 in total. And we end defining that parameter, so we close our brackets. I'm going to select it again, E4. We're going to define our next parameters, which are our actual texture files. So we're going to have param name equals text0. Its type is a int, because we're just sending it a matrix of numbers. And the default for this is going to be 0. And what that means is the default is going to be input 0. These defaults are going to be coming off our inlets. These defaults are taking filling the 4 vector as our the values we define. Next, we're going to do the actual sending these variables into our shader files so that Max knows how to use them. So this is where we tell it what we're actually doing. So we're going to do language, spelled correctly. Language name equals GLSL, no capitals. Version equals, I'm just going to use version 1.0 here. Now, to send these variables into our shaders so that Max can lock them in, we're going to bind them. So we're going to tell it to bind parameter A into the program that we define as FP. So what we're doing here is we're binding this parameter A, which is a 4 vector of 0.25, 0.25, etc. into our program FP, which we're going to define in a minute as this here. And I'm just going to paste another 4 of these, because also into our FP we need to send in our text coordinates. So we're going to send it text0, text1, text2, and text3. Finally, what are our programs? Our programs are name equals VP, its type is vertex, and its source is equals to 4-way mix.vp.gsl. And we're going to do the same for our fragment program as well. Now obviously things like vertex, fragment and bind don't make sense unless GLSL version 1.0 understands what these mean. I know it does, but things like that are important to note. We're going to end our language definition. And finally we're going to end our jitter shader. And then we're going to save that 4-way. The file we need is jxs.jxs, not just JavaScript. We need a jitter XML file, or jitter XML shader to be precise. I'm going to save, I'm going to use .jxs. Now, the problem with this is the Max compiler is both helpful and really clunky to use. So what I can do, I'm going to pass it a read message of 4-way.jxs, see if that works to begin with. So it cannot find 4-way.jxs. So our restart should have fixed that. I'm now loaded in my 4-way.jxs, and now I'm going to do something called dump params. Right, so now it's telling me there's a problem on line 21. So type plus type is meant to be equals. Save it, reload it, and it's telling me there is a problem with text2. So this is saying that there's a problem inside our FP. That's where it is. So there we go, it's now compiled without any issues. If I dump parameters, what we'll see here is it sends out every parameter. So our vertex program is sending out these user-defined texture dimensions into our VP. which has 4 variables at the moment set by us at 0.25, 0.25, 0.25, 0.25, and it also has the input textures 0 to 3, which are coming from our 4 inlets here. So now we can start using Max to control them. So what we're going to do is we're going to add just normal parameter boxes. So I'm going to do param a $1, and I'm going to put a float into it. I'm going to put that into our shader. Change that to B, change that to C, and change that to D. So what this will do now is this will send parameter 1, or parameter A, B, C, and D, and it'll fill all 4 values with whatever number we put in here. So video 1, which is our dozer, you can see here if I turn that into 0, completely turns off. And where they could then adjust the other 3. So 0.33, 0.33, 0.33, so now each of them is taking up an equal third of it all. If we do something like -5 dozer, we start getting something like the invert, so the difference between the two. You can really start playing about with mixing these 4 videos in unique ways. Now there is definitely already things inside Max that do this, but this is being offloaded onto my GPU rather than my CPU having to do anything, so the video will always run perfectly smooth, because that is still run by the CPU. It's just a way of introducing you to what a GL shader is. There's also more we can do with it as well. So I am going to pack param a 0.25, 0.25, 0.25, 0.25. So I want to control all 4 of the values. So not only do I want to control 4 videos, I want to control the RGB and alpha and all of them independently. I'm going to need 4 float values. And then I'm going to put in a U menu to our slab, and then start buying it. You'll see that we'll start interfering with colors as well. Then we can start doing really crazy things. Again, all controlled by our GPU rather than our CPU. For more information, there's obviously the built-in Max tutorials. There is the really good source at the lighthouse3d.com, and they have the Gsl Tutorial Core tutorial, which introduces you to things like the gl.texture matrices and how they all work together, and specifically the sampler 2D rectangle and the texture 2D rectangle, those sort of terminologies and how to apply them. So if you have any sort of basic JavaScript programming ability, you should be able to start creating your own manipulations of video inputs.